Good morning, Seattle Prep Geometry. It's Thursday, March 26th, and I'm just going over answers over DLD 3 and DLD 4. So I'm going to be doing those right now. DLD 3 first. So x squared times x cubed is x to the fifth because you add exponents because there's two x's there and there's three x's there. And so there's five x's altogether. X squared plus x cubed does not simplify. No simple. I might abbreviate here. It doesn't simplify. In order to add things, they need to be like terms. They need to have the same variable, same exponent, and those don't. So you can't combine those at all. X squared cubed, that would be x to the sixth, and this is the phrase power to a power multiply. You multiply the powers together when you have an exponent, something with an exponent raised to another exponent. And so on this one, you just have to remember that this stands for 2x squared times 2x squared times 2x squared. So a lot of kids will get the x to the sixth right. Heck, you just did it on the problem before, but they forget that's 2 times 2 times 2. So that's 8x to the sixth. And so you have to just make sure when you're doing this that you apply the cube to both of them. Those are little arrows there. So one like this, you can just multiply the stuff together that goes together. So it's just multiplying. There's nothing else there. So it's 12 and x cubed times x to the fourth. Add exponents. So that's x to the seventh. And I really like problems like this where the same numbers show up multiple times, but depending on the situation, you handle them differently. So this is, you don't have to do this, but I'm just going to make it make sense. X 8 over 4 times x to the eighth over x to the fourth. And so when you do that, when you do x to the eighth over x to the fourth, you'd be canceling out variables, canceling out x's. So you'd subtract them, and that's x to the fourth. But don't forget, these are just numbers. You don't subtract them. It's 8 divided by 4. So the answer is 2, x to the fourth. So just watch out with those, that exponents and coefficients behave really differently, and you don't apply the same rules to them. All right, and that also happened on this problem here where you had a 2 here and 2 here, but they ended up being different numbers in the end because one was a coefficient and one was an exponent. All right, then we just went over expand and simplify, a little distributive property, 2x squared plus 6x. In my look at your work, most commonly missed question were these two right here, because it's x plus 4 times x plus 4. That's what squared means. It means two of those things, but this is where you have to expand out the binomials. You've all taken an algebra class, so sometimes it might go quick. If you want to leave me a note, say, hey, Mr. Ellinger, could you tell me some more about something? Then let me know. But you're just going to FOIL this. So it's x squared, and then I do the x's in between. So there's a 4x here and a 4x there, so that's plus 8x. So what I'm doing is I don't FOIL and then combine. I use the idea of foiling. I do f and then oi and then ul. So that's my oi right there. That's outside, inside, combined. And then plus last. Cool. Next one. Same thing. It's 2x plus 3 times 2x plus 3. Sound effects make the world go round. And so 2x times 2x is 4x squared. And now that oi, so it's 6x and another 6x. And so altogether, that's 6 and 6. That's 12x and then plus 9. A bunch of you tried to distribute the exponent here and just did 2x, just said the answer was 4x squared plus 9. But there's a plus here, and that makes all the difference. So up above, we could distribute an exponent like in this one, and we could just square each one of them on this problem, on this one right here. That we could just take that cubed and we could cube that and we could cube that. Totally fine. Notice there's no plus sign there. And so you don't have any foiling when you write it all out. But when you write this one out, then you do have foiling. So you can't distribute an exponent over addition is the way math people say it. Last one is just a little pattern that we're going to talk about later, but it's 64x squared. And then doing the oi, you've got a negative 56x and a positive 56x. Whoosh, they're out of there. And so it'd be minus 49 because we have negative 7 plus 7. And this is a common pattern when you have a minus b, a plus b, minus b, a plus b. Then when you FOIL it out, you get a negative AB and a positive AB. The oi cancels out and you don't have it. And so therefore you only get the first term and the last term. All right, now it's factoring. So now it's doing the same thing backwards. So working backwards to figure out what the original problems were. And so this one is x times x minus 4. This is called the greatest common factor one. This one is, and so I'll say a little bit right now. Yeah, I got time. I'll say a little bit right now about how I do these problems. There's all kinds of techniques. There's the X technique, and then there's the what do they call it? Somebody told me the AC method. I've heard of that, and we didn't call it the AC method back when I was a kid. We didn't do that at all. And then what's the other one? Oh, there's the box method where you're looking at it with a box thing, and that's whatever. The problem is that you've all learned different methods, and I don't want to like tell you to unlearn those things. So so make sure if you're getting things wrong, that you talk to me about it, and I can help you and figure out like what you're doing wrong with your method. But the method I do is just called show what you know. Is that you write the problem down, and actually I'll start at the beginning. I'll do this one long form, and then we'll have to jam after that. So so you write down the things you know about the answer. That's the key. And you know this was a foiling problem because we've got that classic trinomial pattern. So we know it was a foiling problem. So the first thing, so some students leave it blank. You know, I don't know. I'm like, do you know anything about the answer? Well, I know it'll have 2 parentheses. Awesome. Then put it down. See, that's the thing. Show what you know. The things you know about the answer, put those things down every time. And don't leave it blank no matter what. And I know that, well, the x at the beginning, the only way to make that is with x and x. And then I'm not going to talk about the signs a bunch right now because I don't have time on this video. And this was just a pretest, so this wasn't the instruction officially. But it would be plus and plus. And then the 2, how would I get the 2? That's from multiplying these 2 together. How could you make 2 with multiplying 2 numbers together? It's 2 and 1. That's the answer. And then you have to check just to make sure the middle term works, and it's 3x. So show what you know. I know it's x and x. Ooh, 6. That could be 6 and 1. That could be 2 and 3. I don't know. Skipping it. Moving on to the next one. My sign pattern, I know it's plus and minus. We'll talk about that. And so I need to make a -5 in the middle, so it's -6 plus 1. Woohoo! All right, now I'm just going to jam because I want to do this in one video. This is x plus 6, x minus 2. This one, well, it's x minus, and it's x minus, and 18x. Ooh, I got to get 18, and I need a lot there. 16 and 2 will do the job. Difference of 2 squares pattern, x plus 4, x minus 4. That's an easy one. This one, ooh, there's a common factor. Let's take the 3 out first and see what we've got left over. And then, oh, difference of squares pattern. So it's 3, x minus 3, x plus 3. I mean, I wrote these problems the other day, but this is legitimately, like, I'm not looking at the answer key here. This one, oh, you could take 16 out. So it's 16 times x squared minus 3x minus 2. And this was a bit of a trick question here. That's as far as you can go because you can't factor the rest of this. If you thought this factored, then you're not checking your work and you're going too fast. So we'll talk more about that. This one, it's got to be 2x and it's got to be x. And it's got to be minus and minus, and so it's got to be 3 and 1. And then this one is going to be 2x and x. And now it's got to be a plus and a minus. Oop, 2x. It's got to be a plus and a minus. Ooh, that's a little tricky. But I do know it's got to be a 3 and a 1. I got to get a negative x in the middle. I should do 3 and 1, and I need it to be a negative x. So, beep, beep. There we go. Solving at the end here, I had a bunch of people use quadratic formula. I could get it on the third one especially because the third one didn't work. but on this one I could kind of get it. But boy, it's such an I don't know. This is such an easy one to do, and I feel like quadratic formula is you're doing a ton more computations that you don't need to do, and it's a lot more likely that you're going to make a mistake in those computations than if you factored it. You just shouldn't use quadratic formula on this for those people who did. So so to solve this, it's x squared minus, I first have to make it equal to 0. We'll talk more about that later. And that's x minus 8, x plus 1 equals 0. Yes. And so that tells me that x has to be 8 or -1. Like that's all the work I have to do. And boy, it's fast, compared to quadratic formula. Next one, x squared plus 3x equals 2x squared plus x. better get to one side. I like the right side because I like my x squareds positive. So 0 equals, I'm subtracting that over x squared, subtract that over minus 2x. Some people did quadratic formula here, but boy, if you can factor this, it's really easy. And then you get x equals 0 or x equals 2. Woohoo! And then this last one, okay, I made a mistake on this last one. This one didn't factor. Apologize. No apologies. But you should have said, oh, I want to get rid of these denominators because I don't like these denominators down here. So I'm going to multiply both sides by x, and on this side the x's cancel. And then I'm going to multiply both sides by 4, and on 4. And on this side the 4's cancel. So you'd get x times x plus 3 equals 4 times x plus 6, which is x squared plus 3x equals 4x plus 24. That was a miss on the plus sign, going too fast. Well, I'm good. I'm at 11 minutes. I am gonna make it. And then subtract everything over. X squared minus x minus 24 equals 0. And I'm very sad. Whoop, I'm not happy. What am I writing? I'm sad with a tear here and a tear there because it doesn't factor. Some of you knew quadratic formula. That's awesome. We're not going over that yet, so I'm not going to include problems that require quadratic formula, and this one did, and I apologize. We're all off our game a little bit, and we're doing our best. In terms of the assignment, if you got to there, then I don't really care what you did after that. If you did quadratic formula, I saw there was a square root of 97 in it. On a bunch of people's pages, I didn't work it out because I just remember I was just feeling sad. So I don't know if that was correct or not. B squared minus 4. Now I feel compelled to find it. Wait, 97? Yeah, 97. Okay. So that's DLD 3. So what you want to get out of this is you want to notice the things you got wrong. So check over your answers and try to look for which kinds of situations you're having trouble. Are you sometimes getting the signs wrong? And if you are, that's a systematic thing that we can fix. You don't want to just say, oh, whoops, I got the signs wrong. Moving on. You want to say, no, okay, like, why did I get the signs wrong? What don't I understand about it? Because the signs should be right 999 times out of 1,000. I think if I was doing these problems, I'd get at least 999 out of 1,000 on the signs. So make sure the signs are right. If you didn't know how to do greatest common factor, we're going to talk about that a little bit in the next video. If you didn't know difference of two squares, go, oh, difference of two squares. When I hear that, I got to make sure I pay attention because there's something I didn't know. I'm just kind of scrolling through looking for stuff. If you missed these ones, then you think to yourself, I am such a conformist because I have so many friends who did the same thing. I'm sorry, I'm not trying to be mean, but it's a really common mistake that people made was to distribute the squared. And it's totally cool. I didn't instruct you or remind you or anything, but what that tells you is that if you're not paying attention and if you're not thoughtful about it, that's a mistake that you're likely to make. So when you're doing problems on a test or something like that, and you see something like this, you should have your spidey sense kind of tingle and make you go, oh, I got to make sure I don't do that usual thing. I think that's it. If you have any questions, please let me know as usual, and hope this clarifies. So remember, go over your answers so that you can see how you did. Okay, that's it.